Thank you. We're ready to have our next session. And it's my pleasure. I would like to introduce Dr. Jason Conviser. Jason is a long-standing medical wellness director, and last year was selected to be one of our medical wellness diplomats, and he's helping us around the globe with international medical wellness. Thank you, Jason.
Thanks, Chris. So I looked at a DVD, or it actually was a tape of about 12 years ago, and I started a presentation with, have you ever thought of a cardiovascular disease where exercise does not prevent, control, or reverse that disease? And my suggestion many years ago was, no, there are none. And then we looked at neuromuscular, metabolic, psychological, all the issues that we deal with from a medical wellness standpoint. And the reality is exercise prevents, controls, or reverses almost every single thing that you can possibly think of in the healthcare continuum. And 12 years ago, I asked the question, then why is it we only have 12 to 15% of the population exercising? Why is it IRSA can only attract a certain group of individuals to come into our facilities? 12 years later, we're at the same 12 to 15%. We've made no changes. So what I'd like to do today is talk about how we can try to attract a completely different group who is not interested in coming to buy a membership, but needs everything we have in medical fitness facilities, in IRSA clubs, in non-IRSA clubs. How do we get a population who's never been here before to see us as a reasonable place to hire and buy our services? Now, as required by the Medical Wellness Association, I need to disclose I am paid by the company that builds a certain piece of equipment I'm going to talk about. But I have no financial involvement, I have no stock, but I get paid for doing this speech. So now I've disclosed my potential conflicts. So imagine, if you would, somebody who's never been in our industry before looks at the concept of osteoporosis, one of the biggest issues throughout the world, and says, I want to go try and solve that problem, and has not been limited by all the things we know and all the things we do to deal with osteoporosis. So the presentation today is, what is it that we could do to potentially cure an entire population of individuals who will be crippled with osteoporosis, with bone disease? So can new technology challenge the inevitability of osteoporosis? We're going to talk a little bit about bone health, just to give you a bullet point review of what it means, what bone is. We're going to talk about osteoporosis and how the industry currently responds to it. Talk about this new technology, but from a research standpoint. And although I can't give you all the data, what we're going to be talking about has been accepted and will be presented at the American College of Sports Medicine meeting in Indianapolis in May, and will also be presented at the European Congress Sports Medicine Conference in Barcelona, Spain in June. And then we're going to talk about, how does this get into your industry, your space, whether you're a personal trainer, a personal physical therapist, a doctor, owner of a clinic, a health club. How does it make sense? So go back to high school or college, physiology or biology, and you'll remember that there are two kinds of bone. One is called cortical bone, and it's the tough, dense outer structure of the bone. And then the internal part of the bone is called trabecular bone, which is the spongy-looking structure. It's inside, and when we look at it, it really is like this, in that this bone is a living tissue. It's constantly changing, and it's always broken down and being reformed. It's not static. It's always in an active process of being broken down, reforming, broken down, and reforming. Bone-absorbing cells are called osteoclasts. And they dig cavities in the inner surface of the bone, and that is an important part of this process of regeneration. Bone building cells are called osteoblasts, and they fill in these cavities with new, fresh bone. Physiology is over. So when people say, well, I don't really understand what that means. So on the left-hand side of your screen, you see what a healthy-looking, we call it a lattice structure of bone, what it looks like. And on the right side is osteoporotic tissue. Maybe a different way is taking a single number 2 pencil and trying to break it, and it's relatively easy. Now take 20 number 2 pencils together and try to break them, and it's very, very difficult. As we age, we take 1 pencil away at a time, making the tissue more vulnerable. If you want to look at what does it look like, you can see a microfracture is a tearing away of that tissue. So it may not be the entire pencil snaps in two, it might be a little small fracture or a shaving away of the pencil. It's not a small problem. This is a problem facing the entire world. And it's not just a big problem now, it's an exponential growth in all populations, in all cultures, and we used to think it was just a woman's issue. Now we know that it's affecting men just as much, or quickly is affecting men just as much. It's a big problem. 15 to 20% of people that have osteoporosis and have a fracture will die in the first year. It's not just a bone breaks, quality of life and the quantity of life is significantly affected. You might see an individual walking with a kyphosis appearance, which is on the right-hand side. Quite often this is many microfractures of the spine. We don't even diagnose it until 5, 10, 15, 20 years later, when we have all these fractures that have accumulated and the integrity of the spinal column is impaired. 200 million potential individuals with osteoporosis, and even more with osteopenia, the precursor to osteoporosis. 33% of women and 20% of men over the age of 50 will experience a fracture at some point in their life. The worldwide cost burden by 2050 is over $132 billion. According to the World Health Organization, osteoporosis is third only to obesity and cardiovascular disease as a global healthcare issue. And this, I find this, a 50-year-old woman who has a similar lifetime risk of dying from hip fracture as she does from breast cancer. There's not a person in this room, whether you know it or not, is not suffering from osteoporosis, has a family member or a significant person in their life or a work colleague who is not dealing with osteoporosis. It affects us all. What are the risk factors? Who is there? Certainly that gender, women do have a higher incidence, but men are coming up quickly. As we grow older, bone degrades and we have more osteoporosis. Having family history is like loading the gun, but it doesn't necessarily mean that you pulled the trigger. You have a higher risk, but you don't necessarily have a cause and effect. Low estrogen. We see it quite often with women who are going through menopause. As the estrogen levels decrease, so does the risk of osteoporosis, and so on and so on. Nobody gets away scot-free. What's really important is, as a culture, we have less and less children and young adults exercising. We have less and less physical activity in our schools. We have less and less everything physical, and yet the formation of the bone is primary up to age about 30. So after we get to the point of 30, it seems to be currently a slippery negative slope. And you can see that even if you work hard after 30, the current literature suggests that it's a negative slope, but it may not be as much as someone who's not exercising at all, someone who's physically inactive. And this is one of the classic, if you can't hear me with the noise, just raise your hand, I'll come back to the microphone. This is a really important slide because you can see that it's possible to have your bone formation to be very, very high, and even if you have this negative slope, at age 80, you still could be higher than somebody else who has very little bone formation in their 20s and 30s. So there's quite a variance with all people with their bone density, but they have a very similar slope, a negative degradation of the bone throughout the lifetime. So it's important to be exercising when we're young. It's important to try to keep that going as long as possible. But it's still negative. So what? URSA, we're here to sell memberships. We're here to get people to exercise. We're here to get people to buy personal training. So what? Those of you who don't know me, my background is I have a PhD in exercise physiology, and I've never cared about athletes, and I've never cared about real healthy people. I care about everybody else, which is about 80% of the whole world. Osteoporosis, diabetes, heart disease, kidney failure, everything that is what I call the real world. And we know that almost 20% of people who have this will die quickly. We know that 6 months after a hip fracture, only 15% of those affected will be able to walk unaided. We know that the risk of hip fracture is equivalent to combining risk of certain cancers. And we don't invite these people into our health clubs. No, they're there as members, but we really don't have programs that are designed to deal with osteoporosis because the literature is very, very clear that we slow the slope. We do not prevent the slope from occurring or even reverse. The way we measure bone and the density of the bone is through DEXA scans. And the number that comes out with a DEXA scan is called a T-score. So if you think about standard deviations, a standard deviation of 1 is that normal bell-shaped curve that we know about, and the 2 lines on the side. We seem to get a big part of the population at least within 1 standard deviation away. But as we move outside of 1 standard deviation, it becomes fewer and fewer and fewer people. Or in the sense of a T-score for osteoporosis, as that number gets larger and larger, the quality of that bone, the density of that bone gets weaker and weaker. So a normal T-score would be 0, right down the middle, to -1, we call that normal. -1 to -2.5 is osteopenia. And if you're -2.5 or lower, which means -3.0, 3.5, you're way off the chart. It doesn't mean that if you have a T-score of -3.0 that you're going to break a hip. But in the same way, if you have resting blood pressure of 160/100, that doesn't guarantee you're going to have heart disease, but you know it's a pretty good indicator that something bad is going to be happening down the line. So people who have negative T-scores of -2.5 or lower, or meaning greater, they are at much more significant risk for having a bone fracture. So what is our solution to date? The best minds in our industry. We control the risks that you can control, but osteoporosis is an inevitable part of aging. That's not Jason's opinion. That's in the medical textbooks. That's in information that is presented by all kinds of organizations and school textbooks. We know that a healthy diet is important. We know that exercising at a young age and maintaining that exercise and trying to slow down the bone erosion and to promote bone building, which is what a lot of the pharmacology does. It slows down the erosion or helps build up the bone building and exercise. That's been our approach. And yet we still have this negative slope. The 9th edition of the ACSM guidelines just came out 4 weeks ago for sale at Coach's Choice Healthy Learning Bookstore. The 9th edition says that you should do weight-bearing exercise. The exercise must be tailored to the individual, but excessive compressive stress must not be put on weakened bones. So there's a problem here is we're supposed to stress the bones as much as possible, but yet the recommendation is don't stress the bones too much because they're already weakened. So more than 100 years of science can probably be summarized by what's called Wolff's Law, came out published in 1892, as a consequence of primary shape variations and continuous loading, or even due to loading alone, bone changes its inner architecture. We knew over 100 years ago, we can change bone. We just haven't figured out how to do it. Now again, this is really important. Those of you who have known me in this industry for 30 years ago, I've never endorsed a piece of equipment, ever. I'm the guy who does or looks at the literature and goes, what's going on? And I believe that if you believe today, which I do, we may have found a solution. 2 or 3 years from now, I think we're going to be in this kind of meeting talking about what is capable of mass production of program and services for a whole population of individuals to deal with osteoporosis. The Surgeon General has made it very clear. Increases in bone mineral density to prevent or reverse the effects of osteoporosis are stimulated by maximal loading. Loading at levels that you're going to go, not possible, can't be done, don't even talk about it. And the literature that we're going to share with you is those loads are possible, those loads are safe. And I'd like to introduce you to my colleague, Dr. John Jaquish, who is not the fitness guy in the industry. He was outside the industry and came up with an idea of how to load the bone in significant ways and how to do it in a safe manner. And then we'll come back and talk about the literature. So please, I'm going to introduce Dr. John Jaquish.
Thank you, Jason. This is an image of the bioDensity device. When you walked in the room, you might have seen it in the hallway. The purpose of the device is putting compression on bone mass. The most simple way to explain what it does. So how does it work? We place users in optimal biomechanical positions. We know where these positions are based on electron myography and reflexive positioning when individuals may want to protect their own bodies. We self-impose loading in these positions. That's very important. When the loading is created by the individual, very little chance of causing an injury because everything is self-regulated by the individual's own comfort. And we have a neuromuscular stimulus that increases the level of density. I'm going to get into that in the next few slides. So increases in bone mass are determined by compressive forces applied. Jason talked about that. Forces that compress and distort the shape of the bone are typically multiples of body weight. When the compression releases, we see in the image, compression releases, osteoblastic stimulation occurs. Now, think about what you know about the drugs. They focus on the outer shell of the bone. Here we're stimulating the entire bone throughout. Now, by looking at a small piece of what's going on inside the bone, as the compressive force deforms the bone, technical difficulty, I don't know, sorry. As the compressive force deforms the bone, we stimulate the inside of the bone throughout. And the nerves inside the bone see that deformation, and those pain receptors within that bone see that deformation and pull more minerals into the bone to recalcify the bone, making the bone harder. So very simply, the bone becomes compressed, the nerves inside see that compression, that deformation. As soon as the compression is released, minerals get pulled into the bone to make the bone harder, protecting those pain receptors. Now, here's an example of this osteogenic loading compression, where you see this individual in the seat. Now, the fixture is in exactly the same position in both images. One, she is ready to start the movement. The bottom one, she is into the movement. You can see the angle of inclusion, meaning the angle right here, between the lower leg and the upper leg. Angle of inclusion changes, yet the seat does not move, and the foot plate does not move. And when she's under compression in the lower image, she's under 1,200 pounds of force. Now, that seems like a lot. She's a mother of 4 children in her mid-50s. I'm glad she's not here. She wouldn't want me to say that. So she's putting that tremendous force on her body, many multiples of her body weight. And she's generating that force. And in that movement, is it possible for her to injure herself? Now, of course, it's always possible to sustain an injury doing many things, but here it is self-regulatory. She is choosing to push into that movement and compress her bone mass. Her comfort dictates how far she can go. And she's seeing on the screen right in front of her, you can see she's looking at a screen, eye contact with the screen. She is using her own biofeedback to determine where she can go. And you can see next to the red dot where it says 997, right in her previous performance, she can see where she was in the previous week and now where she needs to go to best that number. Now, what we have at the same time is a neural inhibition taking place. When the pain receptors within bone receive this stimulus, this deformation, so you see the bone mass, it looks like a spider web of minerals. As that structure, that architecture like Dr. Wolf was describing, as that structure is compressed, the pain receptors, they see that, and comfort dictates how far the individual can go, how great the loading can be. And as that compression is released, those pain receptors they don't like any adaptation, they decide to pull in minerals and protect themselves. So minerals get pulled in to recalcify. Now, if you think about discomfort during conscious movement, we are limiting that discomfort in conscious movement based on the protection of nerve within bone, which takes away a neural inhibition for muscular action. Now, we have 4 movements. There is a chest press, a leg press, a core pull, and a vertical lift. All multi-joint movements, all putting compressive force on long bones of the body. And the biodensity development, 15 years of research and development, 6 years of testing and training. We have over 500,000 data sets with 25,000 unique users. This is possible because the device is server-based. So we collect all the data from all the locations and aggregate it, analyze it, and put out recommendations based on individuals' performances, successes, or failures to succeed in their bone compression treatment. So average 90% force production increases with individuals in a program over a 9-week period. It's a huge neuromuscular change we see because we are recruiting that force with the neuromuscular function. With a small subset of the population that did pre and post DEXA scans, we saw an average 4.5% bone mass gain for individuals in the program over 18 months. One individual had 6% gain in that initial test group in a 7-month period. Another individual had, and this was the worst one, a 1.1% gain in hip density in 18 months. Now, anybody who looks at T-scores and Z-scores and analyzes bone mass density charts or results, you'll know that a gain of any kind is tremendous. Even if, as we saw with the slope that Jason was showing us, as the slope goes down over age, if we can just make that line flatten out, the medical community sees that as a tremendous success, where we're actually making the line go back up and improving bone mass.
Could you just mention that out of the 500,000 users, not a single injury.
Yes, thank you, Jason. Out of the 500,000 users, not a single reported injury. And it's important to point out because when we talk about the levels of force being put through the body, initially everyone asked the question, well, is that safe? That seems incredibly dangerous. You saw the picture of the woman compressing her lower extremities, and it would seem like as we would apply what we know about exercise science to that image, that seems like a dangerous movement. It's really not, because it is completely self-regulatory. Now here we have a pre-DEXA scan. This individual, if you, Jason, if you point at the T-score, she's negative 2.6, no, up at the top. Oh yeah, right there, either way. Negative 2.6, so anything below negative 2.5 is osteoporotic. So this woman has osteoporosis, and she used the bioDensity device for 1 year, and we have some physician comments below in the red box. She increased her bone density by 7.7%, increased her T-score by 23%, and now she's negative 2 T-score, which means she no longer has osteoporosis. She's now considered osteopenic, which is like pre-osteoporosis. So she has reversed her loss and has gained in bone mass. The performance report, these metrics of force production, very important. When we see force production increase, we know without a doubt that the individual is more comfortable in putting greater forces on bone mass over time. So for example, that woman that we saw in her previous session, 997 pounds. And 1 week later, 1,200 pounds. So there's a major adaptation between those sessions, and it's important to point out. You can see this is a typical leg press, and you can see this individual started, let's say that's 650 pounds, and then we see the maximum up at the top, 1,318 pounds. So that's double the amount of force that individual is able to create. Tremendous forces on the body. Now the performance report, it's important to see the whole thing. At the end of every session, individuals get emailed this. This can also be emailed to the physician. So every individual sees every session, every week when they perform this, they see their progress and a complete analysis. And I also have on there the normative data lines built right in. That's actually my business partner's performance report. He'd be very happy that I let everybody examine his performance. Okay, so Jason and I talk about the opportunity and the fact that this measures something very critical and shows an output that people can get great value in. As centers, as medical wellness centers, you all have the opportunity to measure things and show outcomes that people are excited about. And Jason, you ought to really jump in here. This is really part of what you normally say.
The people I think who are attracted to this kind of program are not the people who are trying to get a health club membership for $20 or $15. These are people who are not afraid of spending significantly more money because they're afraid of something health-wise that can be changed. But they don't see the typical health club as the place to change it. Because one, we don't measure very well, if we measure at all. And two, for this particular issue, the traditional way of exercising, even if you followed ACSM guidelines, I'm a fellow of the college, it's my group, it's my organization, we don't even have we can't contemplate the kinds of forces that can be put on the body in a safe manner. So if this is something of interest to you, how might you sell this? And my recommendation, and this is what I've done in my personal business as well as what we do around the world when I consult, is we do 3-month programs. And we do 3-month programs where they come in and we're very, very focused on how many sessions they have in those 3 months. We know that we're going to have significant force production in the 3 months. We know we can guarantee a variety of different things, and they're willing to pay much more money than what a health club membership costs. They don't want to buy your health club. What they want to buy is a potential solution to something that scares the daylights out of them because there's a sense of being out of control. We know we can do it safely. We know we can do it financially, economically to both the potential client as well as the clinic, the personal trainer group, the health club, whatever it might be. And I like the idea. Everyone knows that when I develop programs, you have to have guarantees. But I only like to guarantee what I know for sure I'm going to be able to deliver. And thousands of clients, you know, when we looked at the database a year ago and we saw the 25,000, I brought in a couple people who are much smarter than I am in statistical design, and we looked at that database and we pared it down to 4,000, a little over 4,000 clean individuals, unique individuals. Now it's the largest database that's going to be reported at the American College of Sports Medicine for force production at 4,000. So it's a big group that's all responding the same way. Huge acceptance to these, huge force production and accepting this individual ability to place their body with these forces and keep coming back week after week after week. We sell results. We are successful. When we sell access to walk into a club and we just say, good luck, you're on your own, that's why I think we have many problems that we can overcome with specific programs to specific issues, and we can offer them in our current spaces with our current staff very, very safely. And I think it's an opportunity that if you're interested in, we should talk more about it. Now, you might want to know more about osteoporosis. The International Osteoporosis Foundation, you have a website there. In terms of general information about osteoporosis, not just for the United States, but across different continents, great website. International Society for Clinical Densitometry. If you want to know about the science of measuring bone density, T-scores, what are people doing? How are we making changes? What have been the successes or failures? Great website. National Osteoporosis Foundation. If you choose to create a program for one personal trainer to run, or you want to back it up with your whole organization, lots of marketing materials, lots of contacts to the physicians who might want to make that kind of medical referral. And if you want to go to ACSM, there's the position papers on osteoporosis and bone density. And the company has its own website if you want to learn more. Also, if you're interested, the two of us, with a couple other individuals, wrote a book that is introductory in this osteogenic loading. And if you're interested in a copy, there's an email address that we'd be more than happy to help you learn more about it. Why is this important? I think we are ready, and if we're not ready, somebody else will take over. We need to evolve as an industry. The idea of how we're going to price our memberships, the idea of how we're going to lose 25% of our memberships and hopefully regain them next time. The idea of worrying about whether someone puts a small box next to your big facility or a big box next to your small facility, it's the wrong problem to have. There are plenty of people out there that have disease. And one of the diseases that's very easy to change when we focus on what the problem is as opposed to what you're currently selling, maybe we'll attract much more than that 15%. Maybe people will find their way into our facilities. Questions? Please. So what I'm going to do for the tape, we'll just repeat the question. The question is, what is the protocol for treatment?
Protocol for treatment is 1 time per week. There's the 4 movements done 1 time. There's no repetitions, 1 time per week. And there's quite a bit of trial and error that went into that. And there was also a look towards bone metabolism and how long that really takes. And it can actually be shortened to 5 days, or it can be stretched out a little bit longer. But starting off on once a week is best. Now, there's an algorithm within the software that looks at performance over time, and it looks at normative data, so where an individual should be, where they could be, and it cross-references their age, their gender, and their height, and then looks at what other metrics that may exist to affect their performance, and then on top of that will potentially tell them they need more recovery time or less recovery time. Does that make sense?
This is not, you do not throw away anything that you're currently doing. This is adding to what you're doing. This is supplementing to your existing program.
My other question is, what about people who have had fracture, hip fracture? Is there any contraindications, or is this for the person?
It's a great question. The question was, if somebody has had a fracture, is it a contraindication? The contraindications, there's 2. One is muscular dystrophy, and the other one is unmedicated hypertensive. If someone has had a fracture, now assuming they're not in a cast or they're not under their doctor's care, and they are cleared for regular exercise by their physician, then they can engage in osteogenic loading. Now, one thing to keep in mind is it is self-regulatory. Their comfort may throttle them back to not really where the level that they may think they ought to be, or you as the proprietor of the clinic may think they ought to be, but they are recovering from a fracture. Now, training into that fracture is almost essential. You're giving the osteoblasts within the fracture a reason to grow. Yes?
It's interesting data. Do you have any data that shows a decreased incidence of hip fracture and kyphosis after people have been on this treatment?
That's a long-term study, and we don't have that data. Not actual looks at likelihood of fracture after periods of time. We have confirmed what we know through DEXA scan, pre and post DEXA scan. Now we also do know, sorry, I didn't mean to cut you off. We do know that because the entire bone is being compressed, the entire bone is receiving the stimulus. So it's not like with bisphosphonate drugs, just focusing on the outer shell. This is the bone throughout. Yes?
Does the device have FDA approval for treatment of osteo, or is it only FDA approved as an exercise device?
It is FDA registered. There is no approval process for non-invasive devices. So
That's not true.
maybe I'm misinformed.
There's approval for bedpans. My goodness.
Well, it's the registry process. A lot of companies say that's approved, but there's really nothing approved.
So you haven't had an approval process that goes through that says you can market this as an osteoporotic treatment device?
Yes, we've done that.
You have done that. So you have 510K approval on FDA device
Yes,
as a treatment device?
that's right.
Okay.
Okay.
How about the use of knee and hip replacement?
The question was knee and hip replacement. There have been many individuals who have had knee and hip replacements, and they've used bioDensity with success. Now, it's important to point out that all joint replacements are designed for high impact activity. So they are designed to withstand thousands and thousands of pounds of force. So you don't necessarily have to be concerned about that. And we've had, I don't know, thousands of people that have had joint replacements and had great success, and no problems at all. In the back, yes.
Is there a national registry where an individual could hunt down where one of these machines is located?
Yes, biodensity.com. Oh, sorry. The question was, is there a place where individuals can go to find a biodensity location? And on the company's website is location finder.
Can you just see that?
Yeah, go for it.
I want to make it clear that this is a in-process presentation. A year ago, when I was asked to look at what's going on in the company, I didn't believe it. I didn't believe you could have these forces applied to so many different individuals, and you could have the T-score changes with a wide spectrum of individuals, ages, issues that they're presenting with, and over again, we see that people can live with, survive, are willing to tolerate these incredible forces. Will these forces change the amount of fractures that we see with osteoporosis? I can't guarantee that, but I know the T-scores are changing, which is an indication. Do I know that people will have less falls? Well, the device by itself is not something that would be suggestive of you using it for balance, but we know that when people are stronger, when people exercise and have their tissues stimulated, we know that they have a better chance of being better in balance. But we're not saying it is an only product that you throw away your medications, you throw away traditional exercise. It's additive, and I think the literature is leaning towards an application in addition to the rest of the industry, not an elimination of the rest of the industry. But I guess we're still years away, but we have thousands of individuals who are going through this now because the risk of not doing it is greater than the risks of doing it.
Oh, yes, right there again. Yes? Okay.
Ages 30 and above.
Say it again.
Recommended age.
What's the age recommendation?
We've had people over 100 years old. The age recommendation was a question. Over 100 years old, people have used it. If they can use it, if they're able to actually contract, physically move and get on the device and contract, they can do it.
What you were targeting in your studies, what age group were you targeting?
Well, the studies were different. In the initial test group, that wasn't like a clinical piece of clinical research. So that was a group of people. In fact, the guy you're sitting right next to was one of the initial guinea pigs right there. He looks okay, right? The group was just the group that showed up. You know, we ran an ad in the paper. We wanted to get as many people. We wanted to get 400 people through the device with multiple loading sessions and see what would happen. Now there are studies going on in multiple places that are identifying specific age populations, and well, the one, yeah, Jason can speak on one.
We have a study at a university going on now with women tennis players, collegiate tennis players. We have a group diagnosed with osteoporosis. We have a group that does not have osteopenia or osteoporosis, but is looking at it from a diabetes standpoint. We have another group of a study that hasn't started yet, but it will be starting with anorexia. Anorexics have very poor bone mineral density. If you Google the female athlete triad, it's one of the fastest growing problems that we have with women who participate in sport, and we're going to be working within that context to see if we can again modify or reverse some of the issues with the female athlete triad. So we are trying to get as many independent groups studying different populations to see if there are nuances with both age, sex, exercise history, athletic abilities. We're trying to get as many, that's one of my jobs, is to try to coordinate as many independent labs as possible to do this kind of research.
One session can take a little bit of it. Depends on just the facility and the setup time. Somebody who's elderly and deconditioned may take more time getting in and out of the seat, but basically 10-15 minutes. Yes.
subset from the 500,000 that experienced 4.5% increase in movement. So what was that subset? Is that the other, the majority of the group that didn't get those results? Or what was that group that did get the results?
The question was about the slide with the subset, and we did not do DEXAs on every single one of those individuals. So what we did was we took those who we did have DEXA pre and post scans that were recommended by their physician or their clinical experience, and then looked at those. So it wasn't our definition of assigning to a subset. It was selected independently, and we looked at those data.
Oh, so it's a random set of people that it wasn't
Right.
location.
It wasn't random assignment. It was, we had an opportunity to see who had DEXA scans pre and post, and that by definition became the subset to look at.
Which, in fact, if we go back and look at that, I won't necessarily pull up the slide, but there's different time periods for each individual because they were really physician mandated pre and post DEXA scans. So some of them are an 18-month window and some of them are a 7-month window. And each one of them, and in fact, in the book right there in Osteogenic Loading, these case reports are in the book, and they're looked at each individually as opposed to aggregated. Yes?
Last question?
Well, yes?
What's the difference between maximum load rep training versus using the machine?
I'm not familiar with maximum load.
You're taking a specific amount of weight that you can actually lift in one rep. Just one repetition.
1 hour.
Okay, yeah. The question was comparing 1 rep maximums to biodensity. Well, for example, should I correlate this to bench press of an individual? We have individuals who their 1 rep maximum bench press might be 315 pounds. This is an athletic male, let's say. The first time they would push on biodensity device, they would see a score of, let's say, 900 pounds. Now, keep in mind, they're in an optimal biomechanical range of motion. So very, very isolated range of motion, and the range is very short and has to do with the compression of their bone mass. So they're dealing with, let's say, triple the amount of weight they could functionally deal with in just that isolated position, but they can then adapt and cut back on those neural inhibitors, therefore increase their functional strength through functional movement also.
So you're putting more load on the actual bone itself rather than
Right.
Makes sense.
That's right. That's right. Another thing to think about, if you look at like a straw, a straw is just structurally, a straw is very bendable, right? It's weak when you do this, but it's a cylinder. So if you push end on a straw, it's stronger. And when we arrange bone in that position, like this, so I'm putting force end to end on my humerus, on my clavicle, in that movement, it has incredible structural integrity, and that is also the same way that the osteoblast becomes stimulated when the bone receives force from that direction. That's a great question. Yeah.
If we can, we're our time now, but if you can say they can try it out in the hallway.
We have time for one more question?
I have to tell you, the gentleman who's going to ask a question, I taught a class in Mexico a few months ago, and he's new to our group. One of the finest students, one of the best new personal trainers that you can find. And I hope he asks a really good question so I don't embarrass myself and him.
Go for it.
Well, it's incredible that you discover all the program for osteoporosis and can be stopped. And as Jason is telling that the people who will receive this benefit, they will be like scandalized on the money they expend. I understand like you need this machine and the people and everything that it really work. And how many sessions or how many times that a member or a client must take them to see the benefits, and traducing to your experience, how much it costs a session or how many sell.
Sure. So the question is, how long must somebody adhere to the protocol before seeing a result? And then the second part of the question is, how do you make money? Yeah, I got you. Okay, so the first part of the question, generally, we like 12 weeks, and that's Jason's favorite number too. 12 weeks, you can get by those individuals who may be timid the first time and not commit to 100% contraction in the movements. And then you're really getting into what the individual is gaining, what adaptations are being made from a neuromuscular standpoint and from a bone density standpoint. So that 12 weeks is fantastic. And the way Jason instructs individuals on how to structure their business is you start with that 12-week program and charge, let's say, $2,000. So a heavier charge in the beginning, and then charge per year a lower number. So it becomes very affordable. So they get incredible results up front when they're excited about it, and guaranteed, thank you. Very important that you guarantee them that they're going to make a change. That let's use the number 20%. Their force production is going to change by 20%. So if you walk up to the typical individual and say, I have something for you that's only going to take a few minutes a week, and I'm going to take a metric of your performance and increase it by 20%, you're going to get somebody's attention. Oh, okay. Now, if it's somebody who's osteoporotic, we're going to address your problem. Now, we're not going to increase their bone density by 20%. We're going to increase their force production by 20%, which has implications, as the literature shows us, on bone mass density. So you're guaranteeing them a result in that 12 weeks, and then they have a maintenance program where they pay, let's say, $1,000 per year. That answered the question? Good. Perfect. Perfect. And it was a very smart question, so Jason, you were right. He did great. I think we got to wrap it up. Now, I did want to mention that my friend who makes up for my lack of hair, Doug Parks, wave Doug. That's Doug right there. He's brought a biodensity device, and it's out in the hallway. So he'd love to show it to you. Yes.
Thank you for your time.
Thank you.